No, we don't really set minimum scores. We're kind of just looking at kind of your score holistically and across multiple weeks. We can kind of talk about that more. But yeah, there's
Uh,
no
so,
minimum score or
will I
anything.
have an opportunity to know what I got wrong? Or
Okay, thank you. Thank you. That
Oh,
makes sense.
oh, sorry. Okay. Sorry, actually, for questions, can you guys just type it in the chat? I think it's just a bit easier to digest everything. But yeah, I'll kind of do a full intro once in like a minute or two. I think everyone's filing in right now. Yeah, for what you got wrong. Yes, so we do have like an answer key and we should have the solutions posted. I'll kind of make a note of those things. So I'll get those things addressed for the HackerRank. I'll kind of write it down. Okay. Okay. All right. So I'll kind of address questions after class because I think people have kind of gotten in. So yeah, it looks like the answer of like where you know what question was wrong, you can get a report sent out if you want. Just kind of follow the instructions in the Slack room and they should get all those addressed. All right, so I'm gonna kind of get started. I think if you kind of have more like operational questions about the HackerRank, just feel free to go ahead and post in that Slack room, the one for this class. And I think generally you'll get a response pretty quickly and we'll sort things out and get you all the reports and everything you want. Cool. So hi, just wanted to do like a more in-depth intro about myself. So I jumped in last week. I'm one of the instructors for this class. I'll be teaching, I think, a total of 4 units throughout these 12 weeks. So just to give you a background, my name is Iris. If you look at I'll try to put like instructor as part of my name so it's clear when I'm like jumping into the different breakout rooms who I am. But just to give you guys some background, I am currently a software engineer at Pinterest. I've been here actually close to 4 years. So just to give you a brief intro about my background, I interned at Facebook, a part of the infrastructure team many years ago. And then I also did an internship at Fitbit, also doing infrastructure. And then when I came to Pinterest, I came right after college. So yeah, right after college, I joined an infrastructure team, did that for around like 2.5 years. And then recently I've kind of done a more full stack role on one of the growth teams here at Pinterest. So I've kind of done a big spectrum of like bigger companies to Fitbit, which was a very small engineering team, to kind of like that medium-sized company that Pinterest is at right now. And just in terms of like interviewing, I've had a lot of experience doing internship interviews. I've also done a lot of like new grad interviews when I was interviewing myself. And I'm also on the flip side of things. Like I conduct interviews, both like phone screens, intern interviews, and new grad interviews, and also industry interviews. So I've kind of sat on both sides of the spectrum, and I'm always happy to answer any questions you might have. If you're kind of curious how the experience is at like Facebook or like Pinterest, I'm always free to answer those questions. Cool. So that's kind of just like a brief background. I'll kind of try to monitor some of the messages. It's a little hard to monitor things. Sometimes I don't have time to answer questions as I'm trying to kind of give the lecture. So if there are any questions you feel like aren't addressed, feel free to stay behind at the end of class. And I normally leave like 5-10-ish minutes to kind of answer any additional questions you might have.
Lit.
Okay, cool. So yeah, I guess just in regards with like personally, like interview prepping, I know it's quite challenging. I think the hacker ranks in general are pretty challenging, but be rest assured that we're kind of looking at your progress like holistically. So if you've had a bad week, that's fine. I think the most important takeaway you can have from this class is just honestly, I think we put together a really good selection of questions that actually do come up frequently in like new grad interviews and internship interviews. So if there are any questions that you didn't get right, I'd actually just recommend still reviewing them and don't be too discouraged because it's just naturally like a pretty challenging process. And interview prepping is always something that just takes a lot of effort and time and persistence. It's just something I think you naturally will get better at later on, and like doing a lot of these mocks interviews through this class. So last year we did like a whole run through of this course, and a lot of people said that they saw a lot of similar questions actually in their interviews themselves. So it definitely doesn't hurt to review all the questions we give out, both in like the hacker ranks and the warm-ups. And I think we just give like a lot of different practice problems. Cool. So yeah, that's mostly it. I'll kind of just jump into sharing my screen, and we'll kind of go over the content from today. So let me share my screen. Cool. And all right, so today is actually, I think, the main purpose is kind of for you guys to get comfortable utilizing some of the core data structures. So these data structures come up really frequently in interviews in general. So I think for the most part this week, we just want you guys to be comfortable using a lot of these data structures. They'll actually be utilized a lot in future sessions as well. So there's like a strings and arrays section that's coming up later, and that'll actually heavily utilize a lot of these data structures we're introducing right now. So the point of this week is you should get really comfortable just like being familiar with these data structures in the language of your choice. So you should be able to like understand the libraries that exist for like heaps, especially like you should be super comfortable with like the different hash table functionalities and like the stacks and queue functionalities. So just as like a brief overview of what we'll go over, I'm gonna briefly give some pointers and kind of tips about communicating, maybe some helpful tips about how to get unstuck, because honestly, some of the interview questions you'll probably get are really hard. So how do you kind of make progress when you don't feel like you know what to do? We'll kind of briefly go over heaps. I just want to kind of recap the, I think, important takeaways that I have and like some information I've gathered from looking at a ton of different questions that revolve around heaps. We'll do kind of an in-class set of exercises, and we'll also briefly discuss hash table stacks and queues, and then we'll wrap up with the second set of in-class exercises. All right, so communication. This is kind of like the topic I'll cover for this session, and it's actually a really, really important part of the interview. So I think what's important is that when you're doing an interview, and especially like the phone screens or like the in-person interviews, part of what you're kind of evaluated on is not just are you able to solve the problem, it's also like, can you communicate well? Do they understand the solution you're trying to get at? And also just in general, like interviewers want to get a sense of, is this someone I would generally like to work with? So a few tips I have, you should kind of just generally view it as a collaborative process. I think, yeah, like for interviewing, you can get a spectrum of interviewers. Some can be really unresponsive, not that helpful. But in general, I found that a lot of interviewers are actually trying to help you get to the right answer. So I think it's generally great to view it as a collaborative process where you're talking to your interviewer a lot. You should view it as kind of like an active conversation you're having with your interviewer to try to get to the right answer. So the other thing is be respectful of the interviewer. They're also evaluating, is this person someone I would like to work with in the future? And just, I think, let them talk out their problem. Like, just don't try to rush it and try to interrupt them, because ultimately that will look poorly on you. And yeah, so just keep that in mind. And I think the general thing that I found a lot of people do is when they get stuck and they don't know what to do, they'll kind of just stop talking. And when you stop talking, the interviewer kind of has no way of helping you out. So yeah, I think the key thing to note is that you should keep talking throughout the interview. If you're kind of stuck, walk them through maybe your thought process, so maybe they can help you, guide you in the right way. Honestly, sometimes you can kind of tell them, hey, I'm stuck on this, like I'm trying to think of a way to solve this part of the problem. I'm not sure how to do that. And sometimes like they'll maybe hint you to the right direction. So overall, I think it's a net positive to keep talking. And it'll kind of generally work out in the long run. So I think the other thing that people kind of often fall into the trap of is like they don't actually understand the question fully. So they'll kind of rush into problem solving thinking that they understand the problem. But it's really important, I think, to ensure that you communicate with your interviewer like what you think the problem is asking, probably go through a few example problems just to validate that you actually understand the problem, because if you're trying to solve a problem and you realize later on that you're solving the wrong problem, that's just kind of a waste of time, and then you've wasted a lot of time solving the wrong problem. So this, I think, happens quite often, so it's definitely something that's worth kind of spending a few minutes making sure you're on the same page before moving on. And lastly, we kind of talked about the Empire method. I'm kind of reiterating a lot of the major points there, but definitely like validate your approach before you even jump into coding it out or like jumping straight to whiteboard. Kind of walk your interviewer through your thought process so that they can kind of catch mistakes early on for you. Generally, like an interviewer will let you know if they want you to solve a problem in a different approach or if there's anything they think you should kind of fix. So yeah, those are kind of my general communication tips, and I'll kind of talk briefly about phone screens because I think phone screens, as you guys have experienced, are a bit challenging. Like generally how phone screens happen in industry is that you'll kind of get a link, you'll open up this coder pad, you kind of generally, I haven't actually done any like video chatting, so you don't really see the interviewer's like face or expressions. So I think the point of talking a lot is super helpful for phone screens. Like don't just be silent because it's really hard for the interviewer to kind of gauge what's happening. So I think this is important both for phone screens and in-person interviews, but especially important for phone screens. And just in general, in terms of like communication for phone screens, I think pseudocoding is important for both in-person and phone screens as well. But I found it really helpful to kind of like type up maybe the process I'm thinking of so that there's no confusion with how I'm trying to approach the problem. So I'll kind of just like basically type out a comment plan of like how I'm going to attack a problem in a phone screen. And that generally works out well for me when I've done phone screens in the past. And it's really helpful when I see interviewees do that. So the last thing is for phone screens as well, it's honestly, I've never been in a situation where I was told not to use outside resources when I'm on a phone screen. Obviously, you shouldn't be looking at the answer, but if you are ever like coding something up in a phone screen, feel free to let the interviewer know that you're just kind of verifying like a library or some functions. Like, don't be afraid to do that. Just, I think in phone screens in general, because they can't see what you're doing, keep that communication channel super open. So these are kind of just some tips. Hopefully try practicing these tips also throughout the course. So I think by the end of this course, you'll get so much practice to kind of communicating in general that you'll really, really get good at this skill. All right, so aside from communications, I kind of have a few tips on how to get unstuck. So, oh, sorry, I don't know how that happened. Okay, so did someone annotate? Okay, sure. So cool. So I think when you're stuck, when you see a problem, you're kind of intimidated by it, you don't know what to do. Honestly, the first thing is maybe just kind of walk through a few examples very manually. So go through a few examples and try to get a sense of if there's a pattern you can detect. So I found that in the past, like sometimes while I'm kind of working out through a few examples, that will kind of shed light on some kind of pattern that I've missed, maybe just upon initially hearing the question. So it's super helpful to do this. It kind of also buys you time to think more about the problem as you're kind of walking through an example and seeing if you can come up with a solution. Sometimes also I find that when I'm interviewing people, a lot of people will be completely silent. So it goes back to that point where maybe think out loud, like tell them what data structures you're thinking of using to tackle the problem. And generally like maybe they'll hint you towards the right data structure or like the right algorithm. So it's always super helpful to kind of think out loud. And then, sorry. Yeah, so a few other things to note. I think you might be pressured to come up with like the most optimal solution. I think if it's not immediately obvious what like an optimal or efficient solution looks like, you can first like tell them, hey, I know that I, at the very least, can come up with this brute force solution. So let them know what the brute force is and kind of do some basic time and space complexity. But at the very least, I think it's good to have a solution that is out there rather than to have nothing. And then you can kind of just optimize as you go along. So it's fine if sometimes you like can't come up with the best approach. I think at least put in the effort to kind of make some progress on like coming up with an approach that's slightly more efficient. So making like incremental process is always good as well. So I think basically sometimes, especially when you're doing like so many interviews, there are bound to be problems that are really, really challenging. I think what they want to see is that you put in a lot of effort and that you're kind of making progress to the right solution. So the last thing is just at that point, like, don't give up, like, keep up a good attitude. They're also trying to see, like, hey, is this person, as I've said before, are they like fun to work with? Like, do they have that drive to kind of push through that problem? So yeah, that's mostly just kind of like a brief summary of all the tips I have. And I'll kind of go through the next section. So cool. So the first data structure I kind of want to start off with is heaps. This should be a really, really brief recap. So you guys should know what heaps are. There's like min heaps and max heaps. Honestly, the language I'm most comfortable in is Python. So it's for whatever language you're most comfortable in, definitely just know the heap libraries very well. And with heaps themselves, they're a very handy tool. And you should kind of just know that basically in a min heap, the minimum element is stored kind of like at the top, and likewise for a max heap, the biggest element is stored at the top. So I think with heaps, you want to be super familiar with the different runtimes. So when you are just reading the largest or smallest elements, you should know these runtimes off the top of your head so that when you're using a heap, you can do a runtime analysis super quickly. So by like the end of this week, you should have these down very quickly. So an insertion is log n, a deletion is log n, and the interesting thing is when you create a heap from a list, it's actually O of n. So the key kind of like heap takeaways that I want you guys to have, and I want you guys to remember as you're thinking about what data structure to use for what problem, is that it's really useful for kind of getting like the largest set of values or like the smallest set of values. And you're not really necessarily looking for something that's like a very fast lookup, a very fast deletion, or like a very fast search, because they're not really storing it in a sorted manner. So that's the key takeaway for heaps. And it's a really common data structure for a lot of these like top K element style questions, which I think you guys definitely saw in the warm up. So I took a few examples of what these problems look like. So automatically when you see like top K or like find the K biggest, K smallest, whatever the parameter is, you should automatically think like, how can I utilize a heap with that? And this question actually comes up really quickly or really often. So you should be very comfortable like applying a heap to this style of problem. I think the only other thing is building a heap from a list can take over n time, which is really good. It's like a slight optimization that you can mention that you know, which is pretty impressive. And yeah, so sometimes you can perform an optimization by building a heap from a list. So storing everything in a list and then building a heap directly from that list rather than having to insert into that heap n times. That's like a slight optimization in heap creation. And you kind of just be super comfortable with the heap libraries for the language you code in. So we'll kind of be using these data structures later on. And I think the goal by the end of this week is that you know all these libraries. Obviously, you can kind of look them up when you're doing an interview, and that's always okay. But at the very least, you should be pretty aware of how to use them. It's always good to have comfort and like be very comfortable using them rather than having to learn how to use them on the spot, especially if it's such a common data structure. Cool. So, sorry, I am kind of trying to keep track of the chat, but it's a little active. So if there are any kind of questions that you have lingering, like I'll also address them at the end of class. I'll kind of stick around and make sure I answer some questions. So there's actually like a guide written up for heaps. So if you need some reviewing of that, I'd highly recommend you do that now so that you know how to use these tools like later on in the future units, and also like obviously for the assessment you'll have later on. Okay, cool. So I'm kind of actually looking at the questions right now. Yeah, actually, so the exercise we're going to do is kind of just like going through the process of implementing a heap. I think you should kind of know the technique of how like bubbling up and bubbling down kind of works. So I've actually gotten an interview question a really long time ago where they asked me to implement a heap. That doesn't come up very often. Normally you can, as long as you know how to use it, that's fine. But it's fair game, like a question where they just ask you to implement a heap. Yeah. So I'll kind of walk through the in-class exercises, and what's funny is that a lot of people are asking, do we need to know how to implement? And that's actually the practice problem I kind of want you guys to do right now. So I think it's good to know how to kind of do it and practice doing it, just because it's good to have that knowledge and know how kind of a heap works internally. I don't think it's too complex to kind of just read up briefly of how it works. So for like the next 20 minutes or so, I'll kind of do breakout groups of 3 people, because we only have, we can only create max of 50 breakout rooms. So we'll have to do this in groups of 3. And basically what I want you guys to do is I want you guys to spend around like 20 minutes to work for the problem. And generally what I'll do is I'll give you guys a 5-minute warning when I'm about to close out the room, so that you guys will have time to wrap up conversations. But the best thing to do would probably be to elect like a leader, not a leader, but just someone who will probably like code up the problem, and make sure it's an active conversation. Like come up with example input and output for this problem. Come up with some edge cases you can think of that could break your problem as you're coming up with a solution, and discuss as a group your approach before coding, and do some space and runtime analysis. So sorry, someone is asking a quick question. Going back to communication, I feel like I ask my interviewer too many questions and I come off as someone who doesn't know what they're doing. Any tips on how to fix this? So I think sometimes that might be more self-conscious than you think. So if an interviewer doesn't do a good job of kind of explaining the question, I think sometimes what's helpful is instead just to walk through them, like an example set of inputs and outputs you come up with. So if they give you a question and you don't feel like you fully understand it, what I think is generally helpful is when you try to come up with your own example input and outputs and ask them if that sounds right. Like if you actually fully understand the question and what they're trying to ask by the example input and output they provide. And generally, I think across the board, people really appreciate that approach with clarifying a question. They really appreciate when you take the time to kind of fully flesh out that you're on the same page. And I think it's always honestly better to ask questions early on, because I've seen people go and try to implement the wrong solution because they completely didn't understand the problem. And I think that's actually worse than putting in work up front to understand that question. So sorry, that was kind of like a long answer to the question someone had. All right, so I'm kind of just going to wrap up like the instructions for this session. So what we'll do is we'll kind of break out into rooms of 3. I expect you guys to try to get to working code and run through a few examples, because that simulates a real life kind of like phone screen environment. So also when you're done coding, try to run a few test cases that you've come up yourself, because that's also a skill that's super helpful to work through. And yeah. Oh yeah, someone's asking how long we have. I'll give you guys around 20 minutes, since generally for a question of this difficulty, that's around how much time. So I'll give you slightly more than 20 minutes, and I'll let you know when I'm about to close out the room. And just to make it clear what we're working on, let me, go to the tab. So to figure out like what we're doing, go to the week 2 tab. So click the session 1 tab right here. And right here, I've a set of instructions for all these in-class exercises. I think you guys will get kind of more comfortable doing this as we progress through the class. But basically, we'll break out into rooms, do some introductions. If you break out to a room where you're like on your own or like people are unresponsive, feel free to jump back into the main room and we'll kind of try to get things sorted out. I taught this course last year and it happens a lot, so no need to like freak out or anything. The second thing, you should create like a code interview session. So it looks like you have to sign up for an account, but you can actually just try the demo. So whoever kind of is going to code out more of the problem, feel free to create that, send that link to your group, so that way you guys can all be viewing the same link. And then, yeah, so for this session right now, we're just going through the exercise set number 1, which is like laid out right here. And when you're done, if you have time, like feel free to discuss with your group, look through the solution and see if there's a match. But don't look at the solution, I think, until you've tried running the code and some test cases. And yeah, so, sorry, I'm trying to pull up the chat right now. All right. Okay, cool. So it looks like there are no outstanding questions. I'll kind of ask the coordinator to break out into rooms of 3, and the TAs and I will kind of jump around and help in different rooms. So yeah, can we break out into groups of 3? Let's see. Sorry, let's trying to figure this out right now. So I think looking at the time, we'll wrap up at around like 6:50. So cool. So it looks like the rooms are being assigned. And click that join breakout room button. Okay. Why not? All right, so just like a few things to note. If you're ever in a group or in a room where you are the only one, just actually like jump back into the main room. So click the leave meeting or leave breakout room button at the bottom and let us know. We'll definitely get you into a room as soon as possible. So I know someone messaged on Slack about that problem. Just do that. And generally, we're able to sort that out really quickly. So cool. Let me share my screen again. All right, I just kind of wanted to share with you guys some resources that are there just in case you guys might have missed it. There are actually guides that kind of walk through the information you need. I think that are generally pretty helpful. Like there's actually like a guide on heaps that kind of walks through more of the explanation. So in lecture or during these sessions, I'm kind of assuming you've looked over this at the very least, so you understand the material kind of walking into class. Sometimes we'll kind of review certain things, but for this week, like there are some very in-depth guides in case you need a refresher. I know for some people, you kind of might need a refresher on like heaps and all these different data structures. So it's actually all here. And there's actually even like a video that walks through one of the questions from the warm-up. So if you click like video heaps interview question walkthrough, that will actually take you to this playlist here. And it's playlist I made like last year walking through the different actually umpire methods of how you would actually do this problem. So generally, I think for each week, we'll at least have a few guides, except for I think the review weeks. So it's always good to keep an eye out for all those resources there. There's generally actually also like walkthroughs as well. So we try to make as many of those as possible. So before going into session 1, hopefully you've gotten at least some exposure to how you would tackle some of the problems. Cool. Aside from that, I think I was able to kind of jump in a few rooms and I saw I think people were really actively discussing their approach, which was really great. I would kind of love to see some more pseudocoding. So I know some people kind of just jumped into the problem without actually just having like at least some basic structure of how they're doing that problem. And I think there are 2 reasons why you should pseudocode. I think it's helpful for not only the interviewer or like the people you're working with to know the right approach and kind of agree on that right approach. It's also, I think, when you're actually coding things out, sometimes you'll like lose your train of thought, and having the pseudocode there as like some structure is always worth that initial effort. So if for like in-class exercises, if you find yourself running out of time or like the group can't get to coding that in time, I think at the very least, like write out the pseudocode and like write out that, like how you would at least attempt to address that. So I'd actually highly recommend that when you're doing practice problems as well. So that would be great. Okay, so cool. So just to do like a quick recap, let me start presenting again. Sorry, present. Okay, so to do a quick recap of what we went through, it's always good to kind of come up with some example inputs, outputs, like what happens if you're inserting in like a different order, at least come up with your own example inputs and try to reason about the expected outputs. So what if there's like a completely out of order insertion? That's a good example to provide. So if you insert in this order, it should look like this. Think about some edge cases as well, like obviously you start off inserting into an empty heap. It might be a little tricky to come up with edge cases for this, but it's stuff like the null case, the none case, the empty case, like all those are good edge cases to test out. So the last part of it is, I think if we give that 1-minute warning and you're kind of wrapping things up, at the very least, you should try to do some sort of a runtime analysis. This is like a skill you're kind of expected to know very well. So I've kind of been in situations where people aren't able to evaluate their code very well, and that's generally not good. So you should be super comfortable doing space and time complexity. We'll talk about this more and build up on that skill, but I think whenever you're coding something up, when you're practicing on your own, at least do the exercise of some runtime analysis, both time and space. So in this example, the time is log n. That's just the nature of kind of like if you have the input each time by like bubbling up, that's log n runtime. And for space, we used a list, which is O of n runtime. So those would be the space and time complexities of the problem we just did right there. So just before we move on, I'm gonna look at the chat really quickly. Okay, so, all right, so it looks like there's some discussion happening there. So I'll kind of go through the last few data structures that we're practicing this week, and I'll kind of do the reviews really quickly, but there's a guide for each of these data structures that you can go through and review if you want like a good refresher. So for hash tables, it's used for storing mappings. You should hopefully be super comfortable with all the different hash table methods. So know how to insert, delete, do lookups super fast because it's probably the most common, if it's not the most common data structure, it's like probably one of the most common data structures. And just in general, you should know all the different runtimes associated with hash tables. So you should just know that it's O1 for insertion, lookup, deletion, and you should know these off the top of your head. But I think it's also good to know that in the worst case, it might not always be guaranteed that it's O1. So there are sometimes where I'll have discussions with, I remember in the past when I had done interviews, there are discussions I've had in the past where like, hey, like are hash tables actually always O of 1? And the answer is no. Like in the worst case, it can be O of n. And I think it's just good to review the concepts of how collisions work. So when two things get hashed to kind of like the same bucket, which can happen in hash tables, you should actually know kind of on a high level how the different approaches of like hash collisions work. So in the guide we taught, it's covered, I remember writing that guide and kind of writing a bit about that. So I'd highly recommend you review that material, and it shouldn't take very long. It's just good to know the general concept of how collisions are handled. Cool. Okay. All right, so the general high-level overview should be pretty straightforward. If you want to review it, definitely go through and review it. It's probably the most important data structure to know. So yeah, and I'll kind of walk through, I think, the most important things you should know about hash tables. It's honestly a very, very useful data structure. We'll use it heavily throughout this course. So be super comfortable with all the different methods associated with that. So I think you should always keep it in mind as like a potential data structure to use, because honestly, it's a very common tool. I've seen it in a lot of different interview problems. It's used very common. And you'll kind of see as we go along, like how they're used and like the different ways they're used. So it has really good performance for like lookups, insertions, and deletes. That's a good thing to keep in mind. Remember that these runtimes are on average, and in the worst case, they can be bad, but it's okay to, for the most part, use the average like O of one time assumption. So if you need an ordering data, for the most part, hash tables are not very useful. So that's when you would not want to use this. And you should kind of have like a high level understanding of how hash tables work internally and like the general concept of like the hash function and like how collisions work. So in case like you have a discussion with an interviewer about this, it tends to be very brief, but it's always good to know that you're aware of kind of like the worst case runtimes and how those are resolved. Okay, and I just linked to the guide there if you guys need to know. Also, I generally try to put these slides up in, it might be a little obscure, but in the session one tab, there should be a link to the slides. So if you want to follow along to the slides, it should all be there. Oh, and someone is kind of asking about multi-threading. We don't really cover it in this course because I think unless you are going into some more specialized role, it doesn't come up as frequently. So there are only like, in my experience, I haven't gone and asked it a ton. So we don't really talk about like thread safety or like multi-threading and that stuff within the scope of this class. Yeah. Just to address that concern and like questions around that. In general, I don't, it's not that no companies will ask it. Like there are some companies that might ask it, but in general, it's not like the most common type of question you'll get. Cool. So we've now covered heaps, hash tables. Stacks are also a really common data structure. You should kind of just know the general characteristic of a stack. You should just know the stack library kind of well and the different methods to use with stacks for the whatever language you've chosen to code in. So I think when you think of stacks, it's always helpful to think of it in terms of like a stack of plates, in terms of like the ordering, like the first plate you pick up is the last plate you put down, basically. So that's always a helpful way to think about it. So I think just generally the patterns with knowing when to use a stack, it's really common for like parsing questions. So actually later on then in the course, stacks will be super heavily utilized. Will come up pretty frequently, I think, in the strings and arrays section we'll cover later. But generally, when you think of parsing, stacks are generally pretty useful. It's also utilized a lot for like backtracking as well. So backtracking is something, it's also another unit we'll cover out later on. So we'll talk more about like how specifically to use it. You should just know that these are common types of problems that stacks are used for. And then the last thing is, actually there have been situations where like I'm comfortable implementing something recursively, but maybe like an interviewer will ask me, can you actually implement this iteratively instead? And in that case, you can actually emulate like recursive solutions iteratively by kind of creating a stack and explicitly utilizing that stack to model kind of like a recursive call. So if you're super comfortable with doing recursive things, it generally doesn't hurt periodically to maybe attempt to also do the iterative version of it as well. I think that's a pretty helpful skill to practice periodically. Yeah, so yeah, it's actually happened before. I've been in a situation where I came up with a recursive solution. It was kind of like nice and elegant. And then the interviewer then asked me, hey, like, there might be issues of stack frames. Like, can you actually try to do this iteratively? So I've been in that situation where I've had to switch gears. So it's definitely not a bad skill to have at all. And I think it helps you practice like familiarity with stacks. Cool. So those kind of wrap up the key data structures we'll be working with this week. The goal of this week is basically, if we give you questions of different types, can you kind of pattern match it to the right data structure? And so we're trying to build on that skill. So we're doing a lot of exercises around that. And then as we go along in the course, we're going to teach you kind of like techniques that you can utilize with these different data structures like later on. So it's just good to build that foundation. So I'd highly recommend you kind of read through the guides if you're not super comfortable with these data structures, so that you build familiarity with it, so that later on you can just be very comfortable learning these new techniques that'll utilize these data structures. Cool. So yeah, there's not a ton of content. It's more just, are you comfortable with like the runtimes? Like, it's always super important to know runtimes for all these data structures and any data structures you'll use. Okay, so, and the last data structure we'll talk about is queues. It's the kind of the opposite. You're storing objects in a first in, first out kind of fashion. So the first thing you put in is the first thing you'll get out. So it's common terminology to use, so be comfortable with that. And I think there's not a ton to say about queues, but it's really useful to use when the ordering of the data matters, because it preserves, obviously, that ordering. All right, so for the last half of class, we're kind of just going to be working out like familiarity with these data structures. So we're going to have kind of like a last set of exercise problems that you'll do as a group. So this general structure is, in this session, you'll get pretty comfortable utilizing this, working collaboratively with people to try to come up with a solution. And the next session, so the one on Saturday, we'll actually do a real like simulated mock interview. So for today, it's just like group exercises, so that hopefully by Saturday you'll feel more confident to do problems on your own. All right, so I know Tony talked about the umpire method. It's kind of like a clever way to kind of outline, I think, a very good process. I didn't actually know about this process until I started helping teach the class, but I think in general, it's really good. And I think a lot of people don't do their due diligence in trying to apply this method. So we're definitely going to talk about this method a lot, because it's, I think, a good framework to tackle a problem. So I'd highly recommend you get comfortable utilizing this method to tackle all the problems you're doing in the class. So especially in like the mock interviews, the ones you're doing in person, like try to always understand the problem. I think a lot of people already miss this first step. They think they understand it and they just don't. So always, always, always just clarify. Like, even if there's any kind of doubt on whether or not you know what the problem is asking, just spend the time. It'll be like 2-3 minutes just to validate that your intuition is correct. So then I think this week we're building more of the skill of matching, and throughout the different weeks in this course, you're kind of building out that skill of what are the different techniques and how can you match them to the different problems you're seeing. So after that, it's super important to do some pseudocoding. I think I've seen the pitfall of a lot of people avoiding this step and just jumping directly into code. But as I've said before, it's way easier for your interviewer to help you catch mistakes if they see something wrong in the pseudocode. So pseudocode is always helpful. So I think pseudocoding is also great because you can kind of like plan out what you're going to write out without having to be bogged down by the syntax. So you can just be like, hey, I'm going to create the stack. I'm going to add something to the stack. And you can kind of worry about the syntax later on as you're actually doing the implement step. And then that way, if you have a good plan and pseudocode down, the implementation step should hopefully be pretty straightforward. You can use your pseudocode as a guide to kind of lead you to the right implementation. So after that, like hopefully your pseudocode is pretty good. You'll kind of implement your code. And then last thing is, depending on the setting, if you have time left over, your interviewer, especially for phone screens, it's pretty common for your interviewer actually to ask you to run through your code. So you should be getting pretty comfortable, I think, throughout this course with debugging your code and running it live. And that's something I think you'll practice throughout this class. Like you should be super comfortable coming up with your own edge cases to run through and like thinking about all the different inputs and outputs you'll run your code through and practice that skill a lot because it will come up in phone screens. And actually in a lot of companies nowadays, they will do questions on laptops instead of whiteboarding. So they might also ask you to actually do it in person. So it's just a good skill to have overall. And then last but not least, even if you don't finish implementing and maybe like an actual interviewer, they'll generally ask you to do like the performance. They'll generally ask you like, what is the time complexity? What is the splice complexity? It might actually happen as you're like planning and pseudocoding. You'll talk about it even before you implement the code, but it's always good to practice that skill because in almost all interviews I have, it's something I have to do. I always have to give the space and time complexity. They always want to know how good you are at evaluating the performance of your code because it's a very important skill also in industry. Cool. So we're going to do, I think, a longer set of exercises. And for this set of exercises, we're going to once again split into groups of 3. Definitely start off with like introducing yourselves. I'm also kind of checking okay, so sorry, I'm checking the group chat to see what people are saying. So for testing, is doing only unit testing sufficient? Yes, so normally they're just looking for like you to write up a few like input-output cases, and it's also a way for them to validate that your code works. So they want to see you come up with the process of like creating the test cases and like running the test cases and you debugging your code. They also do like to see that you are capable of like debugging your own code. And okay, and someone asked a pretty good question. I'm going to go back to the slide. If there's a time constraint, which parts of Umpire would you prioritize? Okay, so if you feel like you're in a time crunch, hopefully you understand the question. So you at least understand like what that question is. And the next thing would be definitely prioritize like the pseudocode. Yeah, so definitely prioritize the pseudocode part as well. So I think understanding and pseudocoding, and at least if time permits, trying to get like a skeleton of the code on the screen. If you don't get around to like testing it and running it, that's okay. At least get the first like 3 steps, I think, out of the way, like, or 4 steps out of the way. And generally, like if your interviewer wants you to do time and space complexity, they'll ask you explicitly like, hey, what is the runtime of this? And then, so someone asks, is it ever wise to draw your thoughts on a piece of paper while explaining what you're drawing instead of typing in a code editor for a phone screen? So I think phone screens are definitely trickier. I think what's great about this class is you're getting a lot of good practice. Actually, when I remember doing phone screens back in the day, I would actually have like a separate pen and paper out. So that's like a general good tip, I think, is when you know you're doing a phone screen, just have pen and paper next to you so that you can maybe draw things out if that's easier for you to do and communicate that to your interviewer, like what you're doing. So yeah, it's just, unfortunately, that's just the nature of like how phone screens are. It's a little harder to communicate, but definitely would recommend you have pen and paper. Cool. So I think I'm just going to finish up with like the instructions for the in-class exercises, but I'll kind of keep track of like what's happening in this chat. So introduce yourselves. The objective is kind of to try and go through as many of these problems as you can. So some of these problems are meant to be like more of like a fast warm-up problem. So hopefully you can at least get like maybe 2 or 3 out of the way. So, oh, sorry, let me get that. So let me just kind of walk you through the exercises you'll be doing so that it's kind of clear what's happening. So if you go to week 2, once again, return back to the session 1 tab, you'll go to in-class exercises set 2, and you'll see that there are a few challenges. So I there are 4, and right next to each of the problem, there are around like the set time I expect it to take. So what we'll do is probably throughout the class or like throughout the session, we'll just send out an announcement like, hey, maybe it's a good time to move on to the next challenge. So we'll help you keep track of time, and we'll do this for around like 30 to 35 minutes, and then we'll wrap things up. So for each problem, I would recommend you to try to implement it, try to get it running, and then there's actually like links to the solution, but don't look at the solution until after you've tried to validate like your approach. And yeah, so someone asked a question privately, but I'll just mention it. So the solutions are actually in different languages, and we're trying to kind of be language agnostic. So feel free to use whatever language you're comfortable in. Designate a leader, and that leader can kind of pick the language they want to code in for that question and just switch off. So in general, when you're in groups, people might be using different languages, but ideally, like, you should be able to understand like the high level overview, and you guys should agree on the right pseudocode before kind of that person who's leading the implementation will go in and implement. So for each question, just switch off. There'll be 3 of you. And if there's 2 of you, just then take turns. So that'll be the general kind of like gist of this set of exercises. So there's an approximate time. Remember the umpire method. And yeah, that's mostly it. So follow the same steps as what you were doing before. I think most people were able to kind of create that link. So do create like a separate link per problem. And the TAs and I will kind of jump into different rooms. So we'll kind of be there to kind of monitor and see how things are going. And once again, if you have any problems with the room itself, jump back in. So Elena, can we break out the rooms?
Sure.
Okay, thank you.
Rooms are now open.
Cool. Sorry about the like confusion in the middle. I think screen sharing is super helpful for us TAs. It kind of makes that conversation a bit easier for us to have. So for the like last few minutes of class, I'll kind of just do a recap of the problems. Let me present. So yeah, so in general, as I think we're going through these different, one sec. Let me share my screen. Okay, so let me start this. Okay, so just as a recap, have one person screen share if possible at all times. And I think have the person who's like leading that problem do the coding. I think it makes it slightly less complex to do that system. So I like that. I think screen sharing is also, it kind of replicates like the real world interviewing environment. So I think it's really good to get comfortable like debugging and like explaining and walking through your process, even like sharing with someone else your like Stack Overflow process. That's something that you might be asked to do in like a phone screen. So yeah, problems 1 and 2 were kind of just good hash table practice. I think some people just got maybe somewhat deep into problem 3, but I think problem 3 is kind of great practice for building out a data structure. It's actually, if you look at the code, it's not too complex, but it's, I think, a really good problem to review because it kind of introduces like a very, I guess, unique technique. So I'd highly recommend, if you didn't get a chance to finish that problem up, maybe attempt to do it on your own and then look at the solution. So I think a general tip I have is for a problem like problem 3, where they're asking you to kind of build out that data structure and implement the different methods in that data structure, I think it's good to kind of test each method along the way so that when something is broken, you can kind of validate why it's broken. So overall, I think that's generally a very good technique, and I love it when people do that when they're testing their code along the way. Yeah, and then problem 4, I don't think most people got to. I threw it there just in case some people were overachievers, but it's just another good practice problem with heaps. So if you really want more practice with heaps, that's another problem you should look into. So just as a reminder, I think if you didn't get a chance to look over all the practice problems, I'd highly recommend going through it and go over the guides if you don't feel completely comfortable with all the content. we're going to try to do a mock interview session on Saturday, so it'll be more kind of simulating what it's like in the real world. So the other thing is just review the Empire method. It should be really fast. It's just something I think you need to work through and like get really comfortable doing. And if you have some time, just kind of go through and read how to kind of be a good mock interviewer so that the person you're helping has a good experience and vice versa. I put the links for the guides we have up here. So if you have the time, kind of go through and look over them. And yeah, that's mostly it. I'll stick around for like a few minutes if you have any questions, and I'll try to answer people's questions. Yeah, so someone asks, so basically the class is over, and if anyone wants to just stick around to hear me answer some questions, I'll be around for like 5 to 10 minutes. So someone asks in the beginning, you said brute force is fine. Can you share how to climb up from brute force to a better solution? So many interviewers do not want brute force. Yeah, so I think in general, when you're first given a problem, I think the best approach is maybe spend some time thinking about it. You don't need to necessarily have an answer immediately. And I know in like a time pressure setting, you feel obligated to rush out and give out an answer. But I think take the time to think, like, do you know the brute force solution? And if you do, can you optimize it and kind of do some of the thinking in your head? And if you can't come up with like an immediately obvious optimal solution, tell them, hey, there is a brute force approach. I know if we were to brute force it, like this is a general approach of what could work. So at least I think if you're truly stumped, like mention that you have a brute force solution. So that's, I think, the situation where I think it's fine to say the brute force because having some solution is better than nothing. I think in terms of climbing up from a brute force to a better solution, start of data structures that you think might make sense. So say your brute force utilizes like, is it utilizing like data structures at all? Like, is it just something where maybe you have like a triple for loop? That's not necessarily efficient. Like maybe walk through your methodology. Yeah, so Atia mentioned like a good approach. If the brute force is like n squared times, like think of like the next better thing. What is it? Is it like n log n? So I think that's good advice. Sorry, I'm also looking at the chat. Feel free to chime in if you have any advice. But yeah, I think sometimes it's also thinking about like evaluate like your current runtime and like try to make incremental progress. So like what is the slightly next better runtime? And also sometimes it's helpful to prove to yourself like it can't be better than this runtime. So therefore I know the constraints. Okay, so someone says, what if we can't even get a brute force and the hints the interviewer is giving are not clicking? How can we fail honorably without rambling for 45 minutes? I think sometimes when they give you a hint and it's unclear to you what that hint is, ask for clarification. I think sometimes don't view it as like when they tell you something you must know immediately. It's kind of a conversation. So in interview settings, I'll actually ask questions if I don't quite get their hint, or like I'll try to kind of walk through and like make sure I understand their hint. I'll kind of ask for feedback as I'm going through. So sometimes like some interviewers are really unresponsive, so I'll just say like, hey, actually, like, does this sound good to you? Does this make sense? Like it's like a collaborative process. Someone says, if we waste too much time understanding the problem, is there a way to salvage the situation? So that's a good question. I think some of the better interviewers will let you know, hey, like, let's move on, or like, let's try to get something working first. So I think it's always good to have a grasp of like how long the interview will be. And oh, sorry. Oh, sorry. Can someone mute their chat? I'm just trying to answer all the questions. Yeah, can you waste too much time understanding a problem? I think if you feel like you're at a point where it's like, oh, shoot, I maybe spent too much time asking a lot of questions. I think if you feel like you have like a good footing at that point, just start to make as much progress as you can, maybe at least telling them your solution. So at the very least, if you can't get to coding, at least tell them like, hey, this is what my thought process are, this is the runtime and space-time complexity, and at least make progress there. So at any point where you're like, shoot, I'm running out of time, I think maintain like a level head and just move on to the next step, which is like implementing or like not implementing, just planning out your solution and letting them know. Okay, so someone says, how do you know when you can't do any better in terms of runtime? I think that is something you talk to your interview about. So say like, hey, I'm thinking how I can improve this. Maybe my solution is n log n right now, and I'm thinking of how I can improve this to O of n. But in my head, like as I'm running through all these different approaches, I can't think of a way to bridge that gap. So it's that process, and sometimes they'll kind of hint you to the right direction. But I think how I run through that of like, how do I justify that it can't be any better? I'll kind of look at my code and think like, are there any steps of this algorithm that might be improvable? And if I think to myself, no, I can't really think of anything, I'll let that interviewer know. Like I'll walk them through my thought process and try to justify it to them. And that's normally pretty good. I think if you're super passionate about it, it seems like there's like a Stanford course on Coursera that's centered around the proof of runtime. Yeah. But yeah, I generally think it's really helpful when a candidate just walks me through like their thought process. And that way, if they're like justifying that it can't be any better, if they're maybe on the wrong track, I'll hint them and see if like I can help them make progress there. But yeah, it's kind of like, can you convince yourself that that's true? And like, can you justify it to your interviewer? Okay, so for mock interviews, can we be assigned in advance to know which questions to prepare to? That is most ideal, I think, for a good mock session. So it's pretty hard to have pre-assigned mock sessions. So what I generally like to do is I'll give people like around like 5 to 10 minutes to read the problem they're going to interview the other person for. So that way they at least have some understanding of the problem. Unfortunately, we have not figured out the best approach for that yet, but that's like the best we've done. So someone asked, there are usually multiple questions. If you really can't get the first one, can you ask for moving on to the next one? Yeah, so depends on the company. Some people actually have multiple problems prepared. You don't really know. I don't think you can generally ask to move to the next one. It's kind of just like, can you get the first one? And then if you can get the first one, can you do the second one? So I think just work on trying to get that first problem, because sometimes there's actually just one problem and people won't tell you up front. Okay. Cool. And then someone asks, is this a realistic amount of time, or were we rushing compared to an actual interview? So, yeah, so the answer to that is I think the mock interviews are good representation. I find that phone screens tend to be an hour long, but there's always like 5-10 minutes of you talking to an interviewer. So the breakdown is more or less like you get around like 45 to 50 minutes. So depends on how much time you're allocated, but generally interviews tend to be around the 45-minute to 1 hour mark. And within that time, around 10 minutes is spent chit-chatting with the interviewer. So at the very least, you'll have, I think, around 30 minutes, and then that can expand up to like 45 minutes. So just in general, I think a good strategy is initially when you're like learning new concepts, I like to, or at least when I was kind of interview prepping, I would give myself like slightly longer amount of time. And then as I was getting more comfortable with like these concepts, I would just shorten the amount of time I'd give myself. So as I'm doing practice problems, I think it's really helpful to time box it so that you also don't stress yourself out trying to do a problem for like an hour and a half or two, is like something ridiculous like that. I think at least start off like, hey, can I solve this problem in 45 minutes? Or maybe even like start off with an hour and start cutting that shorter to like 45 minutes, and then cut that shorter to like, you kind of ideally want to be in that like 30, 35-minute mark. That's a really comfortable time to be at. Yeah. And some questions are just really hard, and the interviewer's just trying to see how far you're making it rather than like you trying to answer the question within that time span too. So it depends on the difficulty of the problem. Yeah. Cool. So yeah, I think, sorry, I kind of have to head out soon, but just generally, I'm reading through like generally like the questions that people have. Yeah, I think when you're first initially interviewing prepping, it's really stressful and you get kind of nervous. But I think as you go on, you'll get more comfortable with like time space complexity analysis. And I think you'll just kind of get faster with implementation and debugging in general. So there are times where like I've passed interviews and I haven't been able to fully debug my solution, but I think the interviewer is just generally looking for, are they generally in the right approach? And is their methodology for debugging, like, does it look right to me? I think maintaining kind of like a level head as you're interviewing is just generally a good idea. So I think they're not just evaluated for having like perfect code. By the end of it, it's just holistically throughout the process, like, do I feel like they have a good handle on time-space complexity analysis? Are they good on communication? Do they have generally the right approach? And when they're debugging, are they making good progress debugging? So yeah, that's in general. Yeah, cool. If you have any questions, all the instructors will stay behind in class, so we'll generally try to answer them. So if there are questions you want answered, like we'll be around, feel free to stick around till then and we'll try to answer as much as possible. Thanks guys for coming to class. I'll see you on Saturday. Bye.
Thank you.
Thank you.
No problem.